Oh, hello. Hi. It's me, Sean Astrom. Sorry it's been a minute since I've posted a video, but I got a really cool one here on how to make a super awesome planet inside of Cinema 4D using Octane render and some really neat shaders that I made called Stellar OSL Toolkit. It's 22 shaders and they're really great for making planetary space art or many other things. So if you feel like spending 40 minutes of your life watching this long video to learn something cool, then jump in with me right now and let's do it. First thing I want to do is bring in a sphere, of course, and let's call this planet. This will kind of be our main planetary surface. And let's check out the topology here, and let's make sure we have a lot more segments. Let's go like 256, works well. And then let me hide our geometry there, and yeah, this should work. So I'm going to fire up the Octane live viewer here, and we can see that we have the default environment light going on. So I'm going to go into my Octane settings here, and let's lower this to a black value and fire that up again. And let's bring in an Octane area light. I'm going to push this way off into the negative Z direction. So it's just out there. And let's set this to be a disk. And let's set the size to like something a little smaller here. And then let's crank up the brightness to something like that. And so now we kind of have some basic lighting going on for our planet here. And let's just call this sun, or maybe even more accurately would be star. And then I'm going to throw this into a null in case I want to have, a little bit of control over the position. And this way I can, rotate it around a nice center point, and that all works well. So we are going to use exclusively these Stellar OSL shaders, and let's first start by creating a Octane universal material. This will be our main planet surface. Let's call this planet without a capital L, and we'll throw this shader on here. I like to use the universal material because it really just gives you pretty much everything you would need. But if we go to the Basic tab first, we want to make sure we set the material diffuse, the BRDF model. We want to set that to Orin, Nay, or energy preserving. And this will make the texture, or the surface rather, look a little more rough, which we definitely want. And then we want GGX energy preserving for the specularity kind of model. And then we want to crank up the roughness to a higher value, so let's go like quite high, 0.95, and that is actually going to give us a really realistic, accurate looking planetary surface. And that's really all we have to do on this guy for the initial setup. And what I'm going to do here is bring in, if I right click, I can go into my OSL shaders, and these are all the kind of defaults that ship with Octane. And when you properly install the Stellar OSL shaders, they will show up in a little folder that you create called SA Studios, or whatever you want to name it. And they are all right within here, and it's really nice and quick and easy to load them through here. The one gotcha is the nodes are not named automatically, so I just brought in Stellar Noise, so we'll just call this SA Noise. And this is kind of like one of the 4 core noises that's included here. And within this noise, let's plug it in here, we actually have 5 distinct kind of noise algorithms under the fractal type here. So there's 5 of these. I kind of took great care to get in here and really build out my favorite noises. And this is kind of like a billowy turbulence. We have kind of this rigid mountain. We also have these eroded types, which are quite cool. And I think I might start out with this eroded standard. And if we really look at this, it's got like a really nice organic texture going on, kind of this like pseudo erosion. But you'll probably notice we have some seams going on, and for that we need to bring in a stellar projection. And we're just going to pipe in a normal default octane projection node, but what we can do is under the texture projection type, we want to set this to OSL projection, and then under the script category, we can find that same SA Studios folder, and then within here we want to bring in stellar projection. And then the last step here is we really want to make sure we compile it, because when you load it this way, sometimes it doesn't fully compile, so we just want to hit that compile button. And then just like that, we have stellar projection, which essentially is just like the beloved XYZ to UVW coordinate projection type or mode, but this version has inputs. So we have XYZ inputs so that we can distort the noise. So this is super powerful, and I'll show you this here in a second. But I wanted to also get in here and crank up the octaves a little bit on our noise. And we have two ways of scaling this up. So I built in kind of these quick scale sliders within the noise itself, which is kind of handy. But to really get the most control, we'd want to go to our projection node here, and we have a global scale parameter here, and this kind of really lets us dial in the scale of this noise. Back to the noise here though, there's also a contrast and a bias here, and for this one, I like to kind of just dial it in a little bit, get a little more contrast going in. And then if I go to my light here, it's feeling still a little dim, so I'm going to brighten it up just a little more. And what I also want to do is go into my previews section here in the Octane Live Viewer, and to really have these feel real time and quick, I have found that by disabling the previews here under material previews and OpenGL previews, essentially that's not going to render our material preview down there as well as any shaders here in the viewport, and it pretty much makes this all feel real time. It's pretty wild. But there can be some other weird things that happen when those are turned off. So after I'm done working on all the shading, I will go back in and turn them on. But anyway, this is looking pretty good. What I'm really after with this noise is just getting some nice scale variation. Like I might even crank this up a little more on the scale just so we're getting some nice, dark spots that are large and small. And yeah, that's feeling great, but where the real magic happens is when we start to distort this. So under the X input here, I'm going to bring in just a regular classic Cinema 4D noise, and this is the, OSL implementation of the original C4D noises, and it's actually a really great procedural implementation of these shaders. So I do like to use this in this case, but I'm a huge fan of the Luca noise, and if I solo that, you can see it's just this really cool noise. And if I scale this up, I want to scale it quite large and then add in quite a few octaves. Let's go 15, and maybe that's a little bit big. So what we're after is just, basically a large varied noise here, and then you can see here the distortion that's going on. We're getting all sorts of varied distortion on this initial noise shader here, which is great. If I hop into stellar projection, and we have distortion strength right here. So this is kind of the combined distortion across all these channels X, Y, and Z. So I'm just going to kind of dial that in a little bit, and that's looking pretty cool. And then we also have additional control here, and I'm going to make a copy of this. Let's change the seed and put the scale back to a lower value on this shader, and let's pipe it into the Y, and then now we're distorting in the Y direction and getting even more little micro details going on. And for this, that's kind of what I'm after, is just getting like another level of details there. And when we pull the camera out, you can see we have this like beautifully looking organic surface. And I could play around with these settings all day, but this is actually looking really great. At least keeping this simple, I'm just going to use the one noise for this little demo. I do want to point out, if I rotate the planet around, let's make sure our live viewer is running, you can see the noises are sliding, and that is because our OSL shaders, these classic Cinema 4D noises, are set to texture space. We want to make sure that's set to object space. So if we were to animate this, now everything is going to stick to the surface, and that's exactly what we want. So I am going to put this back to 0 for now, and that's looking really dang good. And then last thing I might do is pipe this guy into the bump. And Octane has awesome bump mapping, like out of the box. It just looks fantastic. No need to do displacement or anything at these distances. So in this case, I'm just going to lower the bump a little bit. And one thing you may find when you're using a really rough surface like this is we do get a little bit of fireflies going on here. And honestly, the easiest fix really for this is to just bring in an Octane camera, and under the tag here, let's go Imager, and let's just enable denoising on here, and then those just go away immediately when it does its quick denoising pass here. So this is looking great, and the next thing we definitely want to do is colorize it, and we're going to bring in one more node for that, and this node is incredibly powerful and definitely one of my favorites out of this collection, and that is Stellar Palette. And let's quickly just name this SA Palette, and we will plug the noise into here, and let me just toggle this on so you can see there's a ton of parameters in here, and it's such a fun shader to play with because it essentially just randomly generates beautiful colors. And you can see just by plugging that in, we got something looking really nice. And if I go into the settings here for this shader, you can see there's quite a few parameters, and one thing that's quite cool is I kind of put in a few presets here under this biome settings. We have like terrain, ocean, desert, mountain, ice, volcano, or volcanic rather, which honestly looks fantastic. And then we have our seed values here, so we can just like get in here and start to randomize these and get some beautiful looks. Now I really actually was quite digging one of these. Maybe it was this one. So yeah, so already this is looking like this Mars-like cool planet we got going on here. And within the Stellar Palette settings, there's a lot to unpack here, so I'm going to do some dedicated tutorials that go through these in much more detail. But you can even plug in your own images to sample colors from, which is a super powerful workflow. But what I do want to do is increase the hue range. So this just basically increases the range of hues. And then we have hue shift, which would be if I want to like kind of push these into, shift them over in the spectrum. So that's looking kind of cool. And then we have saturation range, which is also quite nice. And then we have brightness range. So if I lower that, you can see it's, kind of flat looking. And then if I crank this up, we're getting more distinct definition between the colors. Larger range, exactly what it's doing there. And then this is one of the best parts of this shader, I think, is this random mix. So we have the ability to just add in yet another randomly generated mix of colors as sort of a final touch to really just bring in some nice variation. So if I cycle through the noise, or the seed values rather here, you can see that we're just getting all sorts of random cool colors. So that's looking kind of neat. The trick here is to find something that kind of plays nice with the base colors. And that's, I don't know, you could really play with this for days on end. But I will point out the palette count too. the palette count, so right now we have 16 colors going on, and what I actually find for planetary surfaces, if we lower this value, we're going to get something that looks a little more, accurate, maybe you could say, where we just have a few distinct colors going on. And like from a distance, something like that actually is looking really nice. Maybe we add in like one more color. That's looking good. And then I also put in gamma control here. So if you really want to like dial in kind of how these are being mapped right within the shader here, you can do that. But yeah, honestly, that's looking pretty darn good for this demonstration. Quite happy with that. Again, like you can play with this stuff for days on end, and I don't want this tutorial to be 2 hours long. So yeah, for everything we got going on here, I think I'm quite happy with the planetary surface. Next up, we are going to jump in and build in an atmosphere. So we'll just go ahead and copy the planet geometry, and let's name this Atmo. And we'll remove that shader, and let's check the size of it. So for this, obviously we want it a little bit bigger, so let's make it a radius of like 102. That's looking good. And of course we want to create a new material, so let's go with a universal material again, and we will name this Atmo. And the preview is not generating, remember, because we have that disabled here in the previews, material previews, and OpenGL previews. And again, this just really speeds up as you're doing this type of shading. With these procedural shaders, there's like no lag, and it's pretty amazing. So inside our atmosphere shader, or material rather, let's see what we can do here to get a cool atmosphere going. So essentially, what we're really trying to do is create like a big ball of air, basically. And if I go to my basic tab, we want to definitely make sure we set our diffuse model to Aura energy preserving. And same thing for the specular model, we want to go to GGX energy preserving. And I think that is probably the most accurate models we have here in Octane. And then under the roughness, again, we want to kind of crank that up. So we'll go pretty high value, 0.95 is good. And then we're actually going to really kind of fake this atmosphere shader in order to make it essentially render real time, super quick, without doing any real volumetrics, which you can get beautiful atmospheres doing that. But for this purpose, I have found that this is really kind of the best way to go, because it's just like real time. So under our opacity tab, we're actually going to use this. This is kind of going to be how we like do this atmosphere. So if it was just an atmosphere of gray smoke, this would kind of be what we have here. But I have created an actual atmosphere shader for this type of thing, and I'm just pretty stoked about it. So it's called Stellar Atmo, and it's at the top of the list here. And if we just bring in one of these, you can see straight away we have some inputs and our output here, and quite a few settings. And this is pretty advanced, but really what makes it advanced is there's actually 3 atmosphere models in here. We have A, B, and C. So you could essentially have 3 sun star system where light is coming from 3 directions. But to keep this simple, we're just going to use the one model, and I'm going to plug this into our albedo, and you might be able to see something going on here, and there's definitely some things we need to dial in first. And the first of those is definitely the projection. We want to plug in just a regular XYZ to UVW is fine for this. And then I'm going to go into my shader here and crank up the opacity so we can really see what's going on. And then I might even bring in a black body emission so we can view this through the emission channel as we're kind of dialing it in. But if I do that here, let me actually just turn off the albedo. I'm going to turn off my light here, and then under here we have our strength, which I think the big issue here is we need to set our atmosphere radius to match our planet here, or the atmosphere here rather. So we set a value of 102, so let's go 102, and just like that now you can see what we got going on. So since this is now in the emission channel and we have no light turned on here, you know, the shader, the atmosphere it's doing its thing. And I built in azimuth and elevation control, and that allows us to basically place these lights with these sliders, or where the directional light is coming from. If I zero that out, that's actually going to kind of match where we've set our light here. And you'll see under intensity B, we have 2 light sources going on. So that's kind of what I was looking that way. So I'm going to just drop this to 0. So now we're only doing the 1 atmosphere, and it's looking pretty good. And if I unplug this now and plug it into the albedo, and we turn on our light, now you can kind of see what we're getting here. And then if I go into the material and I increase the opacity a little bit, and now you can kind of start to see what we're getting. So we're going to go back to our starlight here, and we're going to crank this up even a little more in the brightness value, maybe even a little more. Okay, that's looking pretty good. And if I go into my atmosphere shader, and let's actually name this real quick, SA Atmo is fine. You'll see, you know, we have our inputs here for color, so I want to bring in an RGB color here. Maybe even a Gaussian color would be better, but for this purpose, I'm just going to do this because this essentially allows us to tint the atmosphere. And then if I go into the atmosphere shader here and crank up the intensity, you can kind of see what we're getting, this really nice, physically correct atmosphere actually. So even just these settings I feel like are looking pretty good. I do want to increase the intensity a little more. Let's just put in an even number here, and then maybe the saturation a tad bit. And yeah, it's again, like with any of these shaders, it's super fun to play with. I could spend hours tweaking the settings to really dial in the looks here. But I think for this, I'm just going to go with like a warm kind of light. And yeah, that's feeling kind of cool. So you'll probably notice that we have a hard edge here. And we're going to kind of do another fake to kind of get rid of that. And for that, I made a fall off shader. So this is Stellar Fall Off. We'll just type in SA Fall Off for this. And really, I'm going to put that down there. If we plug this guy into the opacity, essentially, if I solo it, we have a nice linear fall off. And the key term there is it's linear, so there's no fancy Fresnel fall off going on here. It's very linear fall off, and that's what we want because we want to be able to just isolate that edge, and essentially we're just going to mask it out. And so I can just dial back this fall off start, and the end control is handy, but I might leave this to 0 for right now. And if I unsolo this, we should see now that we're getting a nice kind of fade out there, and I can adjust that even further and really kind of just dial that in so it just kind of looks like it's fading off. And I think for this purpose this is looking good, but the issue here is we lose our opacity, so now it's completely blanketing the planet underneath. And for that, easiest thing to do is to bring in a Stellar Levels, which is absolutely one of the best nodes. Essentially, this gives us Photoshop-like levels, which is super powerful. It kind of replaces, at least for me, the regular gradient map node. There's still some things you can do with that node you wouldn't be able to do with the levels node, but for something like this, it's beautiful. It's exactly what we need because I have my out max here, and I can just lower this value. And now I'm kind of getting that opacity control back. And if I just solo this, play around with this slider, you can kind of better see what's going on. So that's exactly what we want in this case. And now I'm kind of blending our atmosphere with the planet underneath. And really, this is already looking pretty great. Like, I don't really see a whole lot more I'd want to do. Maybe I can go into our color here and increase that saturation a little bit more. But one thing that's actually kind of fun to do is play around with our light color. Like if we make this sun temperature a little warmer, and then I go to my atmosphere, and maybe now our atmosphere is like a cooler temperature. And yeah, that's looking really darn cool. I'm feeling like the distance is a little extreme here. So I might go into my fall off here and see if we can't like dial that in a little better. There we go. That's looking good. Again, like you could just keep playing with these shaders for days on end, and that's what makes them so fun. But trying to keep this video to a reasonable length, I don't want to go too crazy here. So I am going to hop in to the camera. I like to just call my cameras camera A, B, C, D, whatever. And then let's put in a nice telephoto lens so we can really start to get like some spacey vibes going on here. And yeah, so that's kind of the basic atmosphere shader. We'll get rid of the black body emission, and yeah, you can see here just a few nodes. We have our Stellar Atmos shader, fall off levels, and that's it. And it renders instantly. So last but definitely not least, we're going to jump in and do some rings shaders now. So for planetary rings, what we're going to do is let's bring in a plane, and let's call this rings. And I'm going to hop out of this camera here, and let's just get a little different angle going on here. And I might hide the camera as well. So I've done planetary rings a number of different ways over the years, but I have found this way kind of gives us the most control. So what we actually want to do is bring in a circle spline, parametric circle spline, and we have our rings here. Now I'm going to rotate this at a slight angle so we can get some nice lighting on here to see what the heck's going on. Let's definitely create a new material. We will call it rings. Let's jump into it here. And for this, the rings shader actually might be the most complex, which is kind of funny because you would think maybe the atmosphere or the planet's surface might be. But there's a couple things we want to dial in for the ring shader. But I'll throw that onto the geometry there. And let's make sure we go through these settings again. And then roughness, let's crank it up. I kind of wish there were some different defaults in here, but that works for now. So again, if I right click, go to SA Studios here, we have a ring shader. Pretty stoked on this one. It just has a really neat feature about it. But if I plug it in here to the albedo channel, we can see what we got going on here. And then for this, we actually want to just make sure we're using the mesh UVs. And I'll explain here in a minute, but just like with many of these shaders, there are quite a few parameters, and that is by design because the whole goal is to kind of incorporate all these things into singular shaders. So you just had, instead of a giant mess of 55 nodes for this type of stuff, you only have like a few nodes. So with Stellar Rings, you'll notice we have some kind of strange green coloring going on. And the reason for that is this output is actually a packed RGB output. So if I bring in a special node here, Stellar Split, which is nothing more than an RGB splitter, we'll call it SA Split here. If I plug that into here, and then into our albedo. Now you can see we're actually just getting a black and white image. If I solo this, we have just what I call height, which doesn't necessarily have to mean height for every shader, but these are just kind of labeled this way. So now we have green. The green channel is outputting a mask, which is really handy. And then we have a random ID here, which isn't really applicable for this ring shader, but works on some of the other shaders. So if I go back to the height channel, which is what we want these grayscale values. You can kind of see out of the gate we have some really nice rings. But the issue with doing it this way is if I actually copy the geometry over here and I'm going to connect this up here, you can see that we are getting a seamless transition with our rings here. And that is because I purposely built in looping noise here. So if I uncheck this loop here, you can see that we are definitely getting some seams, and that is an issue with building our rings this way. And so I solved that by basically making this noise loopable in the U direction and in the V direction. But in this case, we don't need to worry about the V direction, just U. And let me delete this second geometry. And really, for this to work, all we got to do is I'm going to zero out the coordinates here. We're just needing one magical deformer, and that is the spline wrap deformer, one of the best deformers, definitely. So we'll drop that in as a child of the rings here, and then under the object tab, let's just bring in that circle spline, and voila, we have beautiful hexagonal rings. No, we need to hide that deformer because I don't like it in the viewport there, and we definitely want to make sure we go into our segments here in the width and crank those up. So this is the actual topology. Let me just show you here on our plane. So I have found you do actually want some pretty high values here. So like 400, that's fine. We don't actually need any in the height direction here. And then we do have our height setting. So a value of like 1 looks good. Let me refresh the live viewer, and we can see what we're getting. And now you might be wondering, will I still see these hard lines? We definitely want to make sure we go into our circle spline, set the interpolation here. The uniform is actually fine, but we want to crank that up to like 64, or let's even go 128. And that'll pretty much make sure that our rings are looking nice and smooth. So I'm going to hide the geometry there again. And really, that's about it. So at least this is in terms of the geometry. So now I'm actually moving the circle spline around, and now we have this nice, beautiful rings geo, but with built-in UVs automatically, which is really handy because another thing I put in this shader is the ability to kind of fade the top and the bottom. So if I play with these parameters here, you can kind of see there's some fading going on the top and the bottom there, which is really great because if they're cranked to 0 here, we just have these like, hard edges where the rings just stop. And I just wanted to have that control in there. So I'm definitely feeling like these could be a little bit tighter like that. And the other fun thing we want to do is we definitely want to plug this into the bump map as well. And if I zoom in here, you can see we get all sorts of extra little details. And then especially if we kind of crank this up, which is really good. But the main issue here is we basically still have a solid chunk, and that's where that opacity control comes in. So I'm going to copy this split out, and let's go in here and do our mask mode. And then if I plug that into our opacity, now we're actually getting nice, and we can see it occluding our little pseudo star there, and we're getting nice transparency there, which is definitely what we want. But of course, these are looking quite boring as this gray color. So let's definitely bring in a stellar palette. I'm going to right click here. We'll bring in stellar palette. And again, I wish these would auto name, but that is one kind of limitation with this. But as long as you like to stay organized, which I highly recommend, you can just type it in here. Let me scooch these over, give us a little more room. And same kind of thing here. For this one, it's actually kind of cool to crank up the palette count. Let's see if we can't maybe match the color of the planet a little bit more, like with these blues. So if we bring in the ocean biome, that seems to work pretty good. Brightness range, saturation range, I like to kind of definitely crank those up. And really, I already kind of quite like these nice green rings we're getting. If I go to the ring shader, of course, it's procedural noise, so I have the seed value here I can tweak. So that's looking kind of cool. I don't know. Let's put in a random number. And then, of course, we have all sorts of control here. So we have scale variation, which is a really nice parameter to do exactly just that. But yeah, that's looking kind of cool. I keep saying this. I could play with this stuff for days on end, but we don't want to make this video too long. So one thing we want to do, though, with rings like this is we actually kind of want to kind of do like what we did with the atmosphere, where we have a little bit of opacity. Oops, wrong slider. So we kind of want the rings to be a little transparent. And I'm remembering here, of course, we have our mask here ultimately driving the opacity. So what we want to do is bring in another stellar levels. Real quick, I will name this and plug that into there. And if I go to the parameters, I just want to make this more of a gray here. There we go. Let me solo this and you can really see what's going on. So now, of course, we have basically like a partial mask, and I think that's a little more accurate for what these rings would actually be doing in real life. So let me see if I can't just get a cooler angle going on here. And last but not least, and that's why I said this shader was going to be, or material rather, shader material, they're kind of the same, kind of not, but I use the term interchangeably. But we want to bring in a black body emission, and we kind of just want to fake putting in a little bit of emission here. Nothing too crazy, and we definitely want this to be double-sided, and then we want the strength to be much lower. And if we turn off our light, you can see we basically have some, glowing rings, which is cool. And turn our light back on. So we're kind of just faking that a little bit so that we can kind of see them from the back side. Because it really, if you think about them being tiny little bits of debris, maybe it's kind of dust, they would definitely kind of be illuminated like this. I'm going to go back to my camera though, pull it out, and already that is looking darn cool. Maybe the emission strength is a little strong. Just drop it down a tiny bit. And yeah, just like that, we have this pretty darn cool looking planet, if I can say so. But I guess what we're really missing, of course, are some stars. So obviously that's a shader that I didn't want to leave out. So if we bring in a Octane HDRI environment, let's hide it in the viewport. And if we select the tag here and go into our node view, let's get rid of that because we are going to bring in that star shader. So of course it's called Stellar Stars, and we will do the naming thing. We will plug that into here, and just like that, we have some stars. Now, just like with the rest of these shaders, we want to make sure we have the correct projection going on. So for this one, the regular XYZ to UVW works fine. And you can see with this one, I kind of went a little overboard with the star shader because I really wanted all the control you could ever need in the stars. You can animate them, flickering. There's all sorts of stuff here. So again, I will definitely be going in and creating some more in-depth videos on all of these parameters. But one thing that this definitely needs is, let's just kind of scale down the stars because they were a little big. So I have this global scale parameter, which works quite nice. And then we have a global density, which also works quite nicely. If I crank that to 0, no stars, and then crank it all the way up, we have like Hubble Deep Field look going on here, which is pretty cool. But there's actually 3 layers of star shaders built in here. Hardness control, brightness random. It gets a little crazy here with all the control. But one thing that's quick and easy to do is if you just want to do, like, there's this color balance, which will take it to like warm reddish looking stars, or we have cool bluish looking stars. We'll kind of leave that in the middle though. And then there's color variation. Like if I crank that down, those are just like gray, white stars. If I crank it up, we're getting a little more variation there. And then we have color randomize and then color saturation. It's pretty neat. It's a pretty neat shader. It literally, for stars, I spent a lot of time on this one. I wanted to have like the ultimate star shader. So that's what we got going on here. And a couple of my favorite things here are these density inputs. So again, let's real quick bring in our good old classic Cinema 4D noises. Now, if I crank up the contrast here, you can kind of see it's basically masking out a section of the stars, which is what we want, so they don't look quite so flat. And we'll set this to my favorite Luca noise. Let's crank up the scale a little bit. And then if I bring that contrast back to, let's say, a value of 50, then what I actually like to do is go to the color, and we can kind of raise that up, and that will kind of blend in the stars. So we're getting some nice variation on the density, which just looks way more realistic, because that can kind of be the issue with these star shaders, is they just look way too repetitive. And I thought that one density mask wasn't enough, so I added in 2. And then now we have a couple going on, and it's really all about scale variation. So I lowered the scale here, and yeah, I mean, for this demo, I think that is looking pretty darn cool. Let me just crank that up a hair. And then let's tweak the seeds. Beautiful. And yeah, guys, just like that, you have this pretty rad looking space image. It's always fun to play with the camera angles after you've kind of built out your scene to really see what's going on. That's looking pretty cool. And then a little trick here, if we just select our geometry and hit the O key, that will kind of center up the camera. And then, you know, of course, we could always get in here and animate the planet spinning around. And since this is all procedurally shaded, we don't have any seams. There's no issues with that. And if you wanted to use these shaders within like your game, let's say, I will be doing a tutorial on how we can bake these maps out. So, but yeah, I kind of want to crank the bump on this a little bit. Yeah, so I hope you guys learned something cool here with creating planetary imagery with inside of Octane here. And I definitely hope you will check out the SA Studios Stellar OSL Toolkit, which, yeah, we just touched on a few of the shaders. There's a whole lot more, and I'm going to be having a lot of fun with all of these videos coming up here. All right, we'll see you later.